Friends. So, whenever we are designing a system, application, website, anything technical, we'll always face or would be at the crossroad of trade offs. Sometimes when we design, we forget the other part because we are more focused to deliver what we are planning in a particular direction. But this list will help you to keep an eye, like a back conscience. Okay, if we do this, this would be hampered, or we know it's a trade off. So let's look at them. So the first that comes to my mind is consistency versus availability. Consistency versus availability. So you can't have both, that's for sure. Or you can't have both in a very good way. Okay. Even if we have like real world examples, if we have Cassandra prioritizes just the consistency. Okay. And internally, there is a trade off for availability. So if we take, suppose, Cassandra as a DB, then we would be losing availability. If we take HP base, it really prioritizes availability, but then the consistency part takes a hit. I hope you get the idea. So let's look at other points. So let me just number it for you. Okay. The second very crucial part would be, I would say, performance versus fault tolerance. So at one hand we have performance, and the other hand we have fault tolerance. So if we are designing for a very high performance system, somehow or under the hood or via the concepts only, we are taking a hit on the fault tolerance part. So if it is high performant, this is going down. Let me think of an example. So Redis, if we take Redis, it is utilized for in-memory high performance. But the general flavor, it has a limited fault tolerance. But if we have something like Raft, okay, it ensures fault tolerance, but it sacrifices some parts of performance due to synchronization. There may be numerous other examples, but the thing to keep in mind is performance versus fault tolerance. Let's go to the third one. This is very simple or thought of, but still, let's discuss this in the context and let's give some examples. This is throughput versus consistency. I'm just writing in short. And sorry, I told throughput versus consistency or latency. Anyways, maybe a slip of tongue. Uh, so the point here is throughput versus latency. Okay. So whenever we will try to increase that throughput, like handling more and more data, we will generally lose on the latency part. The request would be delayed in general. So high throughput sadly less latency. There may be various ways we can keep improving and try to find a balance, but still, these are like two opposites. Okay, let's take examples on a product level, because system level we understand, we can configure, we can fine tune and other things. But if it is a product which is like industry wide enterprise product, even if they cannot have both of them, that means whatever we are saying or hear of is for real. Okay, so on the DB part, uh, or maybe yeah, let's say Hadoop. Hadoop is optimized for high throughput. Okay, like whenever you want to do batch processing. So these will also help you in system design interviews, where you have to put forward some examples of the different tech or different products that you know. Okay, and also the advantages and disadvantages of each of them. Like, you are in a crucial position and you have to think, okay, shall we go with Hadoop or something else? What will hamper? What does the organization need? What is the long term objective for this project? So all these kind of things would help. So that's why I'm trying to give more real life examples. So if we take Hadoop, Hadoop is really designed for high throughput for batch processing. Okay, but recently we have Kafka also, right? Many messaging systems. If Hadoop is already there, why do we have that? Because it is very fast. Okay, very low latency, and it's like real time data transmission. Mhm. So you either choose between them upon your use case. Okay, let's move forward. This is bit obvious, even non-technical people would understand. Let me just say cost. I will just change the color so that we define opposites. Cost versus performance. Perf. Okay, fine. You'll say how. It doesn't look very like at the opposite end, but let's see through it. So whenever we are trying to have very good performance, okay, what we will do, we will go into the cloud. We will have like specialized hardwares, very high performant RAMs, CPUs, configurations. All these are what, increasing performance, that they also cost money, right? Yep. Product aspects, let's say we can have spot instances, okay, from the clouds. Then we are having some machines which work, right? So like spot instance cost is low, but is the performance really good with all the high configurable and high CPU instances that we can get? No, right? So that's the thing. So spot instances is decreasing the cost, but performance bit dubious. Okay. Okay, let's see what else. Let me think. Which, so there can be n number of things, but I just want to focus on the major important points which would be relevant to all the projects. Ah, okay, Yeah, this is at a lower level, like we have write and read things, right? So either we can make write optimized things, or we can make read optimized things. Mhm. Like if you want to tune the read operations, we'll have to suffer a bit for the write operations. There would be inefficiencies. Example from tech aspect, product aspect. Yeah. Yeah. So for write, I would choose Cassandra. We can have a good high write throughput with this. But the read part, I would prefer something different if that allows. Like I have some dashboards which can reflect after some time, and maybe we replicate data. Just for the read part, I would go with Elasticsearch. So you see, even if we try to see for the database part with a product, it's not very straightforward. Okay. uh I would say something at the code level, because we are in real time projects. All these things look very, very good when we give theory or read or just talk in a conference. Okay. But the real world, the real code, the real project works a bit different, as we all know, right? So here I would say something like code quality and maintainability. Okay. Or I would say, but you get the idea, right? If we want good code quality, we'll have to wait a bit on maybe the speed on which we deliver. Okay. uh Maintainability. Okay. So if we have good code quality, we'll also have good understanding of the things. But to maintain it at a higher level, like when the project grows, right, each one is maintaining the same code quality, going through the code checks, right, and delivering. It can have another sense also, like okay, good quality means I can maintain it very easily. I know the framework and how the things would sit. I am just seeing in terms of the project growth. In turn, it's related to speed only, but I just pointed at as two things. Okay. What else? I think I have covered quite a bit. So maybe let's take the others for another session. Okay. Or I can make a quick list for this and share it on my websites for easy reference. Okay. Okay, guys, thank you. So, as you would see, our approach is like not to have very long videos and not to fancy stuff, but in general sense, give some detailed insights, okay, for the software engineering field. Okay, we are not like going very hands on, but still we want to give the trick, or you would say the keywords that helps for revisions and other things. Okay, so please keep in touch with us. We are having a lot of lists to release and explain. Yep. So let's stay connected. Thank you.